Polymers. Polymers are the molecules having some specific structural units in a repeated manner. So, some structural unit in repeated manner. And this simplest unit are known as monomers. Let the monomer is M and n number of monomers are combined to form a polymer, then we can write the reaction as M n times. And the process of formation of polymers is known as polymerization. Normally, the molecular weight of these substances is very high. So, high molecular weight. Homopolymers and copolymers are there. Homopolymers and copolymers. Homopolymers means the type of monomer involved in the polymerization is only one. That is only one type of monomer is participated in the polymerization reaction. For example, polyethylene or polythene is a homopolymer. Here the monomer unit is ethylene, that is CH2 double bond CH2, and n such type of monomers polymerized to form CH2 single bond CH2 n times. While copolymers means two or more monomer units are involved in the polymerization reaction. So, two or more monomers are there. An example is buna-S. In buna-S, the monomers involved are one is 1,3-butadiene, that is CH2 double bond CH, single bond CH, double bond CH2. This is one of the monomer, and the next one is styrene, that is benzene ring containing CH2. So the polymer formed here is CH2 single bond CH, double bond CH, single bond CH2 and single bond CH2, single bond CH, then benzene ring. And n such units are there. So this is an example of copolymer. Then degree of polymerization. This is the number of monomers present in a polymer molecule. This is the number of monomer units in a polymer. For example, if this is a polythene molecule, this is a polythene molecule. So this is a polythene molecule. So here, so this is a polythene molecule. Polythene molecule means monomer is this CH. How can we find out the degree of polymerization? If we break this molecule into the monomer units, we'll get 1, 2, 3, 4. 4 such units are there. So the degree of polymerization is 4. Then if we talk about the classifications of polymers, different types of classifications are there. First one, based on the occurrence of the polymers. Polymers are classified as natural polymers, man-made or synthetic polymers, and one more classification is semi-synthetic polymers. From the name itself clear that natural polymers are the polymers which occurs in nature, or the polymers which found in nature. Examples are cellulose, starch, natural rubber, etc. Then, synthetic polymers or man-made polymers are prepared in lab. For examples, nylon, Teflon, PVC, etc. Then semi-synthetic polymers means these are the modified natural polymers. That is, natural polymers are modified by some man-made activities. These are called semi-synthetic polymers. So, modified natural polymers. And the examples are rayon, then cellulose nitrate, etc. The next classification is based on the structure of the polymer. We can classify polymers into 3 based on the structure. First one is linear polymer, then branched polymers, and the third one is cross-linked polymers. So linear polymers means monomers are arranged in a linear manner. Monomers are arranged in linear manner. Here, these polymers possess high density. Then their tensile strength is also high tensile strength. And hence their melting point is also very high melting point. And these linear polymers are well packed. That is why linear polymer shows these properties: high density, high tensile strength, and a high melting point. So examples of linear polymers are high density polythene, or we can say HDP, then nylon, etc. are examples of linear polymers. These are linear chains. In branched polymers, linear chains are there, but in addition to that, these linear chains possess branches. So, what happens? Their density decreases. So their density decreases. So we can say these have low density. Unlike linear polymers, these are irregularly packed. Here these are well packed, but branch polymers are irregularly packed. That is why their density is very low. So examples are low density polythene, or LDA, and glycogens, etc. Glycogens, etc. Crosslink polymers means linear chains are there and these chains are cross-linked by branches. So crosslink polymers are linear branches cross-linked together and to form three-dimensional structure. These are three-dimensional polymers, and these are very hard, brittle, and rigid. Important example is bakelite. Example is bakelite. Melamine is also an example. Melamine, etc. are examples of cross-linked polymers. Next classification is based on the method of polymerization. So method of polymerization, we can classify them into two. The first one is addition polymers and the second one is condensation polymers. Addition polymers means the monomer units are usually unsaturated compounds, and these unsaturated monomers are combined in a repeated manner through addition and form a polymer chain. Repeated units combined through addition reaction. For example, PVC, polythene, polystyrene, etc. So if you talk about polythene, the monomer unit is this CH2CHCl. This is the monomer unit of PVC. So if one more unit is coming, then an addition reaction will occur and these two combine to form, these two add to form CH2CHCl and converted into a saturated compound CHCl. So n such units are there, then CH2CHCl n times. Second one is condensation polymers. So here condensation reaction occurs as condensation reaction, that is when monomers combine to form polymers, small units like water, ammonia, etc. will be liberated from the polymerization unit, and usually the monomers are bifunctional or trifunctional units. Bifunctional or trifunctional units are coming as monomers. And examples are nylon 6,6, nylon 6, etc. So If we talk about nylon 6,6, the monomers are adipic acid and hexamethylene diamine. Adipic acid and hexamethylene diamine. So if we write the reaction of these monomers, we can write this as adipic acid means COOH, CH2 4 times COOH, and the hexamethylene diamine is 2 amine groups are there, and CH2 6 times NH2. And when these two molecules combine together, one water molecule will be liberated from here, that is OH. H will be gone away, and the new polymer formed here is CH2 4 times CONH, CH2 6 times NH2. This is the polymer formed by the combination of two monomers. So if we write the elongated chain, then we can write it as, here only O is there, so here we can rewrite it as, and here also NH is there and N such units are there. This is nylon 6,6. Here we discussed about addition polymers and condensation polymers, but the fact is that we cannot always classify the polymers as addition polymers or condensation polymers. So we require another classification. So instead of this classification, we can classify the polymers as chain growth polymers and step growth polymers. Chain growth polymers and step growth polymers. First of all, chain growth polymers. Chain growth polymers or chain growth polymerization means intermediates involved in the reaction as free radicals. So the reaction is done by free radical mechanism. That is, the first step is an initiator molecule, an initiator free radical initiate the polymerization reaction. Initiate polymerization reaction. And the most commonly used initiator is organic peroxide. Organic peroxide. Then in the second step, this initiator combine with the monomer unit and form a new radical species. And in the third step, what happens is this polymerization continues, and finally it combines with another free radical molecule, and the process terminates. So the mechanism will be discussed later. Polymers formed here are known as chain growth polymers. So examples are polythene, PVC, etc. Then coming to step growth polymers, the polymerization is done through condensation mechanism. Condensation mechanism. So bifunctional or trifunctional units are condensed to form step growth polymers. Bifunctional or trifunctional units combine to form step growth polymers, and the polymers are formed through many successive steps. First two monomers condense to form a dimer. Then again it combined with one more monomer to form trimer, and so on. So like this way, the step growth polymers are formed. The examples are bakelite, terylene, etc. Bakelite, terylene, etc.